Welcome to a Decepticon and Autobot walk into a bar. This is a new Python tool for enhanced OPSEC. I'm Joe Gray. I'm alive. I'm doing well. I hope everyone else is doing well. So I just wanted to have the camera on for just a second to demonstrate that I am a live human being. So I'm going to go ahead and kill the camera feed and go ahead and get started with the presentation. So about me by day, I'm a senior OSINT specialist at Complex. Prior to this, I had some experience with Python scripting, but I would by no means call myself a guru, a master, or really anything above slightly competent. One thing I am incredibly interested in is data science, so things dealing with machine learning and specifically natural language processing. And I've been looking for applications for both of those disciplines and how to incorporate that into OSINT as well as OPSEC. And then if that worked out, my plan was and still is now to find a way to branch that into social engineering in some form or fashion. Also about me, I'm a frequent competitor in the Tracelabs Missing Persons OSINT Search Party CTFs. At the last global competition, my team, the Password Inspection Agency, got second place out of 190 teams. If you haven't picked up already, I'm very passionate about OSINT and OPSEC. I also have a DerbyCon black badge for winning the Social Engineering Capture the Flag in 2017. And I have advisory roles in a volunteer capacity with both the National Child Protection Task Force and Operation Safe Escape. Operation Safe Escape on this slide is put in bold because at the end of the day, this tool is something that as I was writing it, it became apparent that it's something that they very easily could make use of for a positive impact in the community and with those people that they call clients. I'm not a programmer or developer, nor am I a mathematician or a data scientist. And honestly, I'm not even an expert when it comes to trafficking and domestic violence and that kind of stuff. These are all things that I'm interested in. And the first two are things that I want to get better at. The third one is something I would like to become more knowledgeable about to the point of making those things go away. That being said, there's a few definitions that I'm going to be tossing around today just to make sure that we're on an even playing field. The first one will be OSINT, which is open source intelligence. Basically, that's information that we get from public sources, oftentimes nearly spoon-fed to us by the subject of the OSINT investigation. It differs from a lot of the other INTs, so things like electronic intelligence, signals intelligence, humans intelligence, because we're not really having to hack anything as if we would with signals or electronic intelligence. We're not having to use any advanced techniques of that nature, but we are collecting information in an intelligence context. Next, we have Operation Security, OPSEC. You may also hear this referred to as PERSEC for personal security, but basically it is making it hard for people to understand what it is that you are actually doing. If you are on vacation in, say, Australia, then you may be scheduling posts to make it appear as if you are still in the office at home or something to that effect. So it's just a matter of making it difficult for an adversary to find out enough about you to be able to cause any form of harm. Decepticon in itself is a term that I've been using over the past few years when presenting at various conferences about using disinformation and deception for the purpose of OPSEC. Now we're going to go into what I like to call vendor land, which these are words that, just like the word cybersecurity, vendors are kind of abusing at times. So to provide the definitions that I'm operating off of, machine learning, basically, that's just the study of the algorithms via learning, meaning that there's some level of memory and carryover from one model to another that allows it to influence predictions and decision making. Data science is basically the study of all things associated with that, several disciplines involved, so that we can gain insight from that. Artificial intelligence, basically, it's looking for, air quotes, intelligence, so that we can attempt to mimic the natural intelligence of humans or animals, so that we can reach our desired outcomes and possibly even attain cognition. Then the final part is a GPU, graphics processing unit. Basically, it is a specialized system primarily built with the purpose of processing images and video, but it is also commonly used in machine learning to speed up processing. By comparison, a lot of CPUs have DDR4 RAM on the motherboard, whereas GPUs are running with DDR6. And then in the GPU ecosystem, they have a certain amount of CUDA cores that allow more efficient processing than what you would get out of a regular CPU. So as we go through this, the problem that this presentation is trying to solve is basically one of the leading ways that adversaries find their ways into the lives of their victims is via social media. And when I say adversary, that could mean abuser, that could mean someone who's just a nefarious actor trying to seek harm to a victim, whether that be through abuse, trafficking, could be political opponents, it could be nation state parties, it could just be threat actors groups. There could be a financial gain incentive for this, or it might just be the product of poor mental health in cases as well. But nevertheless, there's a variety of reasons and ways that this could go about happening. And then, of course, we have the adversaries of opportunity. That's the type of person who gets a brand new credit card, takes a picture holding it up, saying, hey, look, I got a brand new credit card. And then someone's like, I don't think that's real. Show me the back of it. And of course, here comes the next picture that shows the CVV of the card number, and then, well, they're maxed out at their limit very quickly. And that would be considered an adversary of opportunity, either through being tricked, unaware, or deceived into potentially, actually, that's victims of opportunity. The adversaries of opportunity are the people who capitalize on those situations. And the adversaries of opportunity tend to go after that final bullet, which would be people with poor or misguided OPSEC. I was having a conversation with someone I served with in the Navy recently, and it was about the TikTok stuff with them phoning home information and collecting information from the clipboard and other things. And he's like, I don't have anything to worry about. I use a VPN. And that led to a conversation about free versus paid VPNs, and not all VPNs are created the same and all of that kind of stuff. And then he's like, well, I use this particular other service. It's not Quad 9, but it's something similar to Quad 9. I was like, well, that doesn't really accomplish what you think it does. Here's what it really does. He's like, all this time I've been searching for this stuff and I didn't think anybody could see it. Well, it's a good thing we had this conversation. But as we look at other victims, that could be politicians, executives, other public figures, and then, of course, the victims of domestic violence and trafficking. So dissecting some of this possible advice that we may receive from an OPSEC perspective. Honestly, abandoning the account is probably, in many cases, especially when dealing with domestic assault, that is probably the best option, but it's not always feasible, because the adversary may pick up on the fact that this account is no more, and if the person is using another social media account, that adversary could go find that account and continue their path of destruction. Keeping in mind that some people have to use social media for work. For me, doing OPSEC, I have to use social media for work. Fortunately for me, though, I don't have to post anything to social media for work. I just have to have access to look at other people's social media. But if someone's in marketing or sales, maybe even HR or recruiting, they may have to use that social media. And honestly, it begs the question, why should someone have to live in fear and tiptoe around someone else? And, the answer to that is Decepticon, really. Uh, but at the same time, some victims, they don't even know that something's happening until it's too late. So as we dissect this a little bit more, some of the other wisdom that I've heard is, well, just block the abuser. Well, the problem with that is the abuser can create fake accounts. Depending on some of your access controls, you may have things set to friends of friends. Especially if you were in a relationship with someone for any period of time, you are going to have the possibility of mutual friends. And then you also have to worry about if the adversary finds any alternate accounts that you are using that's not the one that they are aware of, they could report that for being fake. And given right now with COVID, Facebook's not doing a whole lot about fake accounts, but if they reported enough from enough accounts, eventually something may happen and you may be prompted for a driver's license number or another form of identification. They can still attempt to reset your password, whether that be successful or not. And then looking at this from like the perspective of an executive, even if you block an adversary as an executive, they can still target your company. And from a realistic perspective, as an OSINT investigator, I'm honestly more skeptical of a subject that I look at that doesn't have any social media presence, more so than any that I look at that has something. Even if it's just a Facebook that everything's set to friends, or they just never post, they have one picture and nothing else, that's not out of the ordinary. Having someone that has absolutely no presence, but everything else within their dossier lines up for that, that certainly does set off some alarms. So honestly, it begs the question that I've got here on the slide: why do we not have autonomy and agency over what is posted with minimal effort? Well, at that rate, enter Decepticon. So regarding the code, here's links to the code. Basically, they're the same link. It's just one's going to get you there a little bit easier than others. I'll give you a moment for that. And then I'll explain the code, explain how the code is built, do the demo, and then work through some lessons learned and what have you. So the code is written in Python. Right now I have two versions. Only one is up on GitHub. One version, the version on GitHub, leverages TensorFlow and Keras. Basically, I'm using the NVIDIA port of TensorFlow version 2.20. I've got a link for instructions to install that on the repo, because this is optimized for the NVIDIA Jetson platform right now. I'll explain that in a moment as well. I did some parallel research with PyTorch. I like PyTorch's efficiency with everything, but I wasn't able to get the accuracy that, and I'm going to use air quotes here, the accuracy that I have with TensorFlow. I wasn't able to replicate that with PyTorch yet. So that's something I'm working on. I use pandas to organize the data into data frames. So basically think of that as kind of like a CSV file or a spreadsheet in memory. If you view a data frame in something like Jupyter Notebook, then it actually looks just like a spreadsheet. But within this, I use Keras to implement the long short-term memory model. And that's what is actually used to analyze and generate the text. So what's a long short-term memory model? Well, it's a type of recurrent neural network. Well, if you're not familiar with that, what's a recurrent neural network? Basically, it takes into account past decisions and how those decisions worked out to influence the outcome. So if it learns something, it has the capability to remember that, depending on how it's stored. And unlike traditional neural networks, they don't have a fixed vector size. And that's very useful when we are talking about natural language. Even though this is pulling from Twitter, we can't say that we have 200 inputs with a vector of 280 characters, because not every single tweet has 280 characters unless we explicitly make it do that. So having a vector size that is flexible works very well for things dealing with natural language, which would include text and speech. And then it's also commonly used in images. So the LSTM learns order dependencies and does the sequence prediction. So that's looking for characteristics associated with the language that you're speaking. So in the English language, if a word ends in Y, we typically pluralize it as ending in IES. There are exceptions to everything. And then if a word starts with a vowel, we usually predicate that with the word an as opposed to a. There are exceptions there as well, but LSTM is going to look for those types of dependencies and perform that type of sequence prediction. So how does the code actually work? Basically, we start with Twitter API keys, and I used the Python Twitter package. There are other packages out there to use if you want to try to replicate this with your own coding set. But I just chose that one. It's very easy to work with. We pull down the tweets. As it is scripted, it will pull down 200 tweets. It'll take a moment to do that because it sleeps on rate limiting. Twitter does have a rate limit on that. If you don't sleep on the rate limit, you're only going to be able to pull down 32 tweets at a time. It's going to read the tweets. By default, the code that's on GitHub only reads the tweets of the owner of the API key. I'm going to be releasing probably, I'm going to say August 1st or that ballpark. I'm going to be releasing a version where you input accounts that you want to mimic so that you can basically use it to manage SOC accounts, so fake accounts that you might use for OSINT purposes or research purposes. From there, we capture the text and the time of the tweet. We convert the time to epoch time so that we can do linear math with it, as opposed to having to count on our fingers and toes days, minutes, and seconds. We also capture what I called lexical diversity, and basically that's the ratio of the words used to the length of the text. It's not really important in this iteration, but in versions 3 and 4, which I'm currently in the process of mapping out right now, they'll be far more important. There's also a fork of this code that I'm looking at implementing as well called Intercepticon. I'm not really going to get into detail about what it is, but lexical diversity will be far more important in it than it is in the current iteration. But basically, we move from there to tokenize the tweets, separate it into words. We could do it into sentences as well, but in this case, we're just doing it into words. We add it to the corpus, and for the corpus, I use the phrase BOW in the code for the variable, but just to create a bag of words. We get a little bit more statistics on the text of the tweets. So we look for things like frequency analysis, most common mentions, most common hashtags, any links that are shared as well. And then we also pick up the post interval, which that is why epoch time was important, because then we can determine about how far apart on average the account posts, so that whenever we set Decepticon and let it run and just walk away from it, we have it posting at something that appears to be us. From there, we move into the generate module. And at that point, we use the length of the text to establish our vector sizes and sequences. We look for the number of unique patterns in the corpus. Then we do a little bit of housekeeping, setting some files up associated with the model so that the tool can repetitively learn from it. If you look at some of Decepticon's tweets from my C_3P Joe account from when it was first starting to tweet, as opposed to some of the ones that it's doing now on the DC865_owl account, which I'll show you, they are vastly different in terms of the the quality. And a lot of that has to do with I've been letting it run repetitively as opposed to starting and stopping it and wiping out the model every single time. So it has the capability to actually learn things now. From there, we move into the trainer module. That's going to build us a pseudo-random seed, and then it's going to assess the predictions, create what is the actual tweet. We have a logic check to ensure that the tweet's short enough to be able to tweet it. And then we remove links, known characters to occur. So things that's not normal to written text. In the beginning, when I first started tweeting as Decepticon, I had a lot of problems with it doing several patterns of an apostrophe followed by a comma, as well as a few misplaced brackets. So once all those things are cleaned out, it tweets. So here's the time for the demonstration, and that's the one thing I did not open in advance. So we kick it off, Decepticon bot.py. It's going to run through. So this is just it doing Decepticon things, getting everything ready, getting the tensors going. Right now, it's not leveraging any GPU. So it's going through, it's connected to Twitter, it's pulling the tweets down. This may be the one that flubs up on me. So there's the frequency analysis of hashtags, all that fun stuff. So we'll go back here really quickly. So as you can see here, in terms of the analysis, in the account that it's analyzing, which I've altered the code for it to look at the C3PJO account, even though that's not what it's tweeting as, I've used hashtag OSINT, OSINT Search Party, Decepticon 23 times, OPSEC, OSINT for good. I did a Rickroll, and while I was training this, there's some stuff with the Raven, T.S. Eliot. I tweeted out All-Star from Smash Mouth, social engineering, some stuff there as well, OSINT the Planet, and CTF. So that's the hashtags I was using. And then in terms of accounts that were mentioned, I've mentioned Trace Labs 4 times, Black Hat once, the DC865 Owl, Hackfest Canada, Dave Kennedy, RDS Web, Cat Stoner, Fatality, and National Child Protection Task Force. So now it's going to look through the characters and vocabulary. And then from here, I'm going to be speeding things up. So it's about to start running through the epochs. This is the time that it goes onto the GPU and executes the model. So just skipping ahead, this is just watching it go. Depending on how big your data set is, the way I've got the code structured now is it writes everything to a data frame, and then from there it continues to store it and then repetitively goes back to it. This is just another video continuing the process, showing how it moves from one epoch to another. So we see that the loss is improved, which deals with the relationship between everything. What I didn't mention is as the long short-term memory model is executing, there's a function within the code that's going to convert all of the letters, all the words into numbers. And as that works, we convert to run the memory model, and then we convert to move it back. So this is just on another epoch. So just speeding all that along, because sitting and watching this is kind of like watching paint dry. It's going to move from this epoch to another epoch. So just moving forward with that as well, just to make sure we have enough time here. So again, it's going to move through that, sits for a minute, and then go with the next one. So with this one, we'll just skip ahead. So it's going to move into the 5th epoch here. So there it moves, and every time we're improving the loss, which is good. With PyTorch, I was able to get a lower loss number, but at the same time, I wasn't able to get the good accuracy with it. So we have that. Now, this is after it's already created. So it had finished the 5th epoch, created the random seed, and then just processed it. And honestly, this is not the most ideal of a tweet, but in terms of abandoning an account, it's accurate enough. So let me go here. This right here is showing as the Decepticon bot stopped and tweeted, it goes into the sleeping period. And I altered the code to get the sleep period to be between 1 and 2 minutes for this, so that I could capture this without having to sit and watch it or record a couple hours of material and then edit that out. So as it works through here, we'll just go back just a smidge. So there, it triggers the code again. It works again. Right here, we see there's the posting interval in seconds. There's all the lexical diversity things I talked about as well. So then it just continues. We go through, runs through everything, goes through. Now it's starting its epochs. And we have that. And then right here is the, this is JTOP running on the Jetson that I'm using. So this is showing it just running through everything before we kick anything off. So we have, a little bit of a memory load. The CPUs are running, but they're not really taxed. The GPU is not doing anything. So as we see right here, apparently my neighbors decided to mow their lawn at 8:30 in the morning. If it wasn't for this conference, I definitely wouldn't have been awake this early. So it's just working through here. And about this time, as we see memory creep up, we're gonna observe the GPU kick on, and there it goes. So this is during an epoch. This is as the model is running on the GPU. So now we see the GPUs pegged out, the CPUs getting more activity. And I gave this a lot of swap space, to be honest, because in the earlier models, it was leveraging memory very heavily, and it was causing the system to actually freeze up and just not be worthwhile. So I ended up, as you can see here, it's got like 48 gigs of swap space because the platform only has 4 gigs of RAM. So I've seen where the swap gets executed to about 2 gigs. Depending on what's going on. In this version, not so much, but in the version that will be taking other people's tweets and using that likeness, that does take quite a bit of swap space. And that's the demo portion. If I wanted to be a really punny metalhead, I could probably say that's the demo Borgir. Notice I'm really passionate about OSINT and a very poor comedian. But anyway, about the project itself, it started around December 2019. And as with anything else, there's plenty of hurdles. I had shiny objects, squirrels, distractions, other things happened as well. And that obviously slowed things down. And in the past, I'd written a few things in Python, like WikiLeaker, for example, which is also a Recon NG module. It basically uses the requests library within Python to search WikiLeaks for existence of a domain. But I'm always trying to push myself further. I'm trying to find ways to marry other disciplines to be able to find ways to do things that are out of the box. Like, for example, last year I was presenting a talk called Social Forensication that basically operated under the pretense that as a social engineer, I would gain access to a facility, convince someone that I needed to take a memory image, take the memory image out and then do offensive memory forensics to be able to pull passwords and other juicy tidbits of data from memory. In the case where the person didn't have domain administrator, that was okay because I had also written a script on a rubber ducky that dumped part of Windows to be able to take the Wi-Fi password. And then I also had a thing where it also did proc dump on Chrome or Firefox to take passwords that may potentially be stored in memory. So anyway, I've been reading about natural language processing and machine learning for some time and how to do things in Python. And the tutorials in the books, don't get me wrong, they're great, but you can only go through the quick fox jumps over the lazy rabbit so many times before you just lose interest. So this project was something that was supposed to help me flex those muscles and learn to fly, if you will. And then with that, I started doing a little bit more work with Operation Safe Escape, and it's like, hey, this would be a really good fit for this. And I've not trained them on the code yet. It's not in use for their clients yet, but that is something that is on the roadmap as well. So also about the project, in March, it stalled. And it didn't stall because I was on the road basically living in an airport. It stalled because everything in the world just changed. I mean, I think we can all agree that our world's changed drastically between February/March and now. But anyway, I was on Brian Brake's CSEC East meetup virtually, and one of the other presenters was talking about this Jetson platform. I was like, what's that? So I started to take a look at it, and I ended up porting the code over and resumed developing the tool that way. Because the VM I was using, I mean, it wasn't weak, but it didn't have like hardcore GPU. I had given the virtual machine 3 cores and 8 gigs of RAM running on my MacBook. So, I mean, it wasn't anything to scoff at, but it wasn't anything to be like super proud of either. And granted, a Jetson Nano platform is only about 100 to 150 American dollars, but it's a little bit nerdier too. So this is the Jetson Nano. The pictures we see on the right is the actual Nano developer kit, the single board. That's what I started with, and then I got to looking into it a little bit more, and I looked at adding the T300 expansion card. So as you can see, that it works via a USB 3.1 bridge. The T300 platform allows you to connect a solid-state hard drive to it. So my current system, I have both a 1 terabyte and a 64 gig solid-state drive. The actual operating system for this is running off a 256 gig micro SD card. So this is just a little bit bigger than a Raspberry Pi. I mean, it's honestly, the board is about twice as wide, but that's really about it. So it's not too terribly big. My current rig, everything involved, costs about 250 American dollars. Specifications on it, it's got a quad-core ARM processor with 4 gigs of RAM, and it's got the 128 CUDA core Maxwell GPU. This is what the case looks like. I have mine in that case with a fan on it. I don't have the Wi-Fi antennas or the camera built in. I could put them in. I just have no desire to right now. But we have the HDMI, the USB, micro USB, and Ethernet. So that's basically what I'm running with. Why did I use this platform? Well, it's external to my regular host, so it's not taking computing cycles away from other things like the book that I'm in the process of finishing. It's not taking away from my ability to give presentations. It's not eating up all my resources. I can still listen to my YouTube music as I'm working, and everything's fine. It has that enhanced GPU so that I can expedite the analysis. When I first got the Jetson platform, I was able to, it took me about 53 minutes for a single epoch on the virtual machine. I can tear through 5 epochs given the size of the data set right now. And depending on which data set, it varies between half an hour and about an hour and a half. So, and with each epoch, it becomes more and more accurate. So that's definitely an added bonus. And then, of course, there was the recommendation that I mentioned. So lessons learned. Data science is not a walk in the park, especially if you don't have a heavy math background. My undergrad and master's are both in IT with focus in security. So officially the highest college math courses I have taken have been college algebra and statistics, not even calculus-based statistics, just statistics. So I had a pretty heavy learning curve with some of that stuff. I learned that PyTorch is faster, but it's less reliable as I've got it programmed right now. It's probably no fault of PyTorch. It's probably totally on Joe Gray, but I haven't got it completed yet. If you test it on your regular account, make sure that you have some stuff of substance. As some of you may know, I offer OSINT training as the OSINTian, and I tweet very frequently of my upcoming course offerings. Well, that came back and bit me because when Decepticon first started running, it was trying to promote training from the past and fictional upcoming training. So you want to make sure you have some things of substance that it can actually operate off of as well. That being said, if all you ever do is tweet promotional stuff, then let it do its thing because you want it to act as much like you as possible. But in this case, I wanted it to seem more like a person that's doing a lot more interaction on Twitter. Also, be prepared for people to get annoyed with you. I got quite a few messages from people acknowledging, hey, I understand you're doing research in disinformation and deception, but the stuff Decepticon's posting is spammy and obnoxious. And honestly, it probably wouldn't have been that big of a deal if I had have stuck to the regular tweet interval. But the thing about the regular tweet interval for me is it was about 12 days in between tweets, and that just doesn't make for any compelling presentations. I also learned that people get confused when you start tweeting things like the Raven. They get a little irritated when you start tweeting All-Star and a Rickroll. And honestly, throughout the whole process, there was a whole lot of hypotheses and a whole lot of A/B testing. There's a lot of let's see how this works, let's see what this changes, and what we can derive from this. Given that this is dealing with data science, which is adjacent to like data mining, data lakes, data oceans, so forth and so on, an array of tweets, around 200 tweets at 280 characters, is a very small data set for an LSTM. So if after some time, after you have your repository built up, then it's going to be a lot more accurate. In terms of limitations, right now it's to make use of the CUDA cores and the GPU. If you do it on a VM or just hardware, it can be very time consuming. I've looked into leasing GPU processing in the cloud, and it seems to be very, very expensive. And then, at the same time, a lot of in the use case for like Operation Safe Escape, people may have completely deleted all tweets, or they may have just set the account up. You're going to need to get something posted for it to have anything to work off of. Alternatively, you may also have to pull from somebody else, as I am doing with my current version of the code right now. So we'll take a quick look at the Twitter account that's posting from it right now. So this is just an account that I had an API key for. So as you can see, about 5 minutes into this presentation, it started tweeting part of the Rickroll. Before that, it was tweeting about the Raven. We wear the mask. So it's pulling stuff from a lot of those different things. So that's this account. Searching here, let me actually. Cool. Thanks. What am I looking for here? Hashtag Decepticon. So looking for hashtag Decepticon. So this is just some of the stuff that I did. I'm going to do some advanced searching on it and only look from my account. This makes it a little bit easier. So there's some Decepticon stuff. And it's not only, I need to add, that's what it is. That's what it's missing. My apologies. So now this is all looking at this. Previously, I'd mentioned Workshop Con Layer 8 because I gave training there. This is just pulling through some stuff. As you can see, it's tagged Black Hat a few times. The tool is being presented at Arsenal on August 5th. But as it just goes through, it just goes through and pulls stuff out. Again, this is not necessarily the most accurate, but it's somewhat accurate enough. So this stuff right here, this is actually pulling from somebody else's tweet. But if we scroll down, notice this right here. This is what I was talking about with the commas and the apostrophes. We see that here as well. And it just got kind of really obnoxious really quickly. But then we'll also take a look at the actual code itself, time permitting. So basically, we'll start here at the absolute bottom as everything's set up. So here, this is set up for future versions to be able to input users. The stop words are not used in this iteration, but I may add them back in another one. That's just removing words like and the and stuff like that. The physical device sets up the GPU for everything. This is connecting to Twitter. So there's an adjacent Python file that you have to input your Twitter API credentials into. I call it t_keys.py. And that's going to reference everything here. And then from there, we have tweet mode extended. That's going to get the full tweet as opposed to a preview. Sleep on rate limit true. The sequential model is putting in the LSTM. And then here, because this is the one that's actively running as DC865OWL right now, I've changed it from get timeline to get user timeline so that it can pull C3P Joes. I'm not looking at replies right now. That'll be in future iterations. So once it goes into login, actually first we do all the imports. That's in this file right here. Quite a bit of stuff to import. I'm probably going to clean that up a little bit and release that soon. Adrian Sanabria, Goldar, Dredjak, Bill, that guy, Nasirasek, and JFerg helped out with some of the coding. James, November, Cheerio, Wondersmith Ray, and Adrian again allowed me to pull tweets from their accounts. But anyway, we log in, we check to verify there's a directory. The CSV file is what we're looking for. If the CSV file exists, we're going to import it because that's what's going to contain the previous tweets. If it doesn't exist, then we just we create it and then go from there. Here we have the lexical diversity, but we're moving from there to tokenization. So here we see that I've created empty lists globally. For the tweet, we pull down the full text, split it. This right here, the regular expressions, that's just going to be able to pull to populate the bag of hashtags, mentions, and links. And then we move to the hopper. The hopper, we've got the full text again. We've got the tweet created at time. And then from there, we have the time of, this is where we're converting it over to epoch time. So tweet created at, then it goes to make time in this format, and then it moves from that format to epoch time. We execute lexical diversity, and then we replace, we just cut out all mentions and hashtags. Honestly, if you wanted to seem even more natural, you could cut those two things out if you wanted to. And then from there, we append whatever's there with the tweets, the times, and the lexical diversity. And then we drop duplicates just so that we don't have undue influence here. Then we move into the sorter. This is just where we're going to build our bag of words and do the tokenization. So from there, we're going to collect some stats, do some frequency analysis. So the stats, this is lexical diversity. Then we're going to look at the mean standard deviation of lexical diversities. So, and then we define the post interval here. Frequency analysis, this is just showing us the word counts for the bags of hashtags, links, and mentions. Then as we get into the generate function, this is where we convert the characters to numbers. The input length is the length of the bag of words, so that's your vector size. Spit all that out. We give it a sequence length of 500. Build everything, set our patterns up, set it up to shape as correct here, run through pre-modeling, which is right here, which we create a JSON file so that we can store the model in that as well. We also, for redundancy's sake, save the model as an H5 file. Here we have everything configured in loaded model compile for categorical cross entropy using the RMS prop optimizer. Beyond that, I've established 5 epochs and a batch size of 32, and then everything just works through on that. And with the pre-modeling, we have if this file exists, this is loading the old model. If not, then it just moves into modeling. So it builds the 224-bit LSTM, and then we have the epochs, the batch size. Right now I'm running on 1 epoch for the first run, and every other one's 5. But nevertheless, and then through the trainer, this is building the pattern. So it's just taking the data that comes from the modeling and what have you. Then we have the tweet creator. So this is just pulling everything, converting it back, building everything into the pattern. And then I've determined that we can have about 40 words and 280 characters fit in. I have all this stuff to remove out any links, erroneous characters, any of that fun stuff. There's definitely a more efficient way to do it. I just haven't done it yet. I'm sure I could just write a script and have it import it and run it that way. But then here we see that it posts the update and that it's appending hashtag Decepticon and mentioning Hack in the Box Security Conference. And then it moves into the repeater. The repeater right here is the normal sleeping interval. You can set that random. I've got it to subtract a random interval from it so it's not too detectable, but you could do whatever you want with that. It sleeps and then it kicks off subsequent, which basically just triggers the process all over again. So that being said, looks like I'm bumping right up against the time. I'll open it up for any questions simultaneously during this portion. If you want to contact me, here's my contact information. Again, there's the GitHub repo. If you're interested in playing with the Jetson Nano platform, there is an Amazon idea list with pretty much everything you're going to need to get started. Also, at the end of the week, I'm offering open source intelligence training. If anyone's interested in attending the training, use coupon code HITB1337 for 25% off. So I'm doing a 6-hour training on, it will be August 2nd. I put that incorrectly on the bottom thing, but August 2nd from 8 a.m. to 2 p.m. Singapore time. And then I'm doing 2 3-hour sessions the days before that from 6 to 9 a.m. Singapore time. So again, if there are any questions, please feel free to reach out. But if there are none, thank you very much. I appreciate your time. Be safe. Thank you for taking time out of your day to spend with me sharing my passion. Thanks.
Thank you, Joe. And as it happens, we have a bunch of questions. But as you also mentioned, we are kind of pressing for time. So trying to keep your answer brief. Have you considered using GPT-2 or GPT-3 for text generation?
I never came across those. GPT-2 and 3, I'm writing those down to take a look at it. I wasn't aware of that.
Okay, cool. Another one is, how big is the LSTM? How much memory does it consume, and how much attention can you give it?
Well, on the Jetson platform, I've been able to run it at 224 bits with 32-bit batch sizes without running out of memory. Because if I tried 256-bit or 512 or 1024, my apologies, I got out of memory errors, even with the swap space. So the LSTM size is going to depend upon the hardware that you have it on. If you're using the Jetson platform and you have it on like an Xavier, then you're going to be able to have more space for it. If you are doing it on like a gaming PC with like a GeForce 2070, then you're going to have a lot more flexibility with it.
Okay, then the next question is, what is the size of the corpus?
The size of the corpus is directly relative to the number of tweets that is ingested into the data frame and the length of the tweets.
And final question, will you be posting a full article or white paper on setting everything up, including building for the Jetson?
You know, I hadn't thought about that, but it is on my to-do list now.
Okay, awesome.
And I will be posting it on Medium and sharing it on Twitter.
Okay, well, brilliant. That is all the questions we have, which is kind of good because we're pretty much out of time as well. Thank you, Joe, for that amazing talk.